In this video, we're going to talk about skewness of the data, and we're going to relate that to the mean, the median, and the mode. So looking at this example here, we have a data set, and they have given us the histogram of that data set. So I'm going to go ahead and find the mean, the median, and the mode for this data set. I'm going to go ahead and also assume it's a sample. So I'm going to use X bar to represent that. And if I add up all of the data, pause the video too, add up all the data, check yourself. I'm getting 112, and I have 16 pieces of data. So that comes out to 7. Okay, since it's in order and there's 16 pieces of data, let's find the middle. 6, 7, 8. Okay, so I'm seeing the middle right there. Let me check one more time. I think I may have just gone one too far. 2, 3, 4, 5, 6. I did. Okay, sorry. Middle right here. There it is. So it's between 7 and 7. So the median is 7. All right. Now the mode, the most frequently occurring data value, that's also going to be 7. Okay, so all 3 of them are 7. They're all the same value. And what we see about the histogram is that it is very balanced. So we call that symmetrical. But there is another phrase I'm going to write down, and that's that it's often called bell-shaped. Bell-shaped data. So those two things are the same, they're linked. And when we're saying the data is symmetrical, what we're saying is that it's kind of like a mirror image. There's a middle point that's kind of this high point, and then the rest of the data kind of just comes right off of that high point like this. All right, kind of flows down from the high point and starts to decrease on either side. Now, it's not always perfect to be symmetrical. Okay, it doesn't have to be exactly perfect like this one, but that is kind of that ideal shape we are calling it when it is symmetrical. All right, so let's look at another data set. So this data set has a different histogram. It's not symmetrical anymore. Let's go ahead and find the mean and the median and the mode. So for this one, when I add the data together, I am getting 63, and there are 10 pieces of data. So 6.3, that's my mean. Okay, so the mode then, I'm sorry, the median then, 1, 2, 3, 4, 5, is going to happen right between 6 and 7. So that'll be 6.5. And then the mode for this data looks like it's 7. One nice thing, by the way, about the histogram is I can see the mode right off the histogram. It's the highest group, right? So the rectangle representing the highest group, that's the mode right there. This type of distribution is called left skewed, or skewed to the left. Wow, helps if you spell skewed right. There we go. Left skewed. Because what we have is most of the data, the bulk of the data is like right here. And then there's a little data that goes out to the right, but then there's way more that goes out to the left. And that's skewing the data to the left, pulling it off to the left. So this last set of data here is the exact opposite. In this data, we're kind of sitting on the left-hand side, and the data is kind of being pulled out to the right. So this is called right skewed. We're still going to go ahead and calculate the mean, the median, and the mode. So for this one, the mean I'm getting is, when I add them all together, I get 77 divided by 10. So I'm getting 7.7. The median here is right between 7 and 8. So 7.5. And I could see from the histogram that the mode is 7. And I want to kind of understand how the mean, the median, and the mode are working based on how the data is skewed. So in general, the first one we looked at, the symmetrical one, the mean, the median, and the mode they were all the same. And in symmetrical data, that's the case. They're very close to each other, if not the same. So that's how we kind of know if the data is symmetrical. For the left skewed data, what's happening there is the mean is actually the smallest value, followed by the median. So it's less than the median. And that's all less than the mode. So the mode happens to be the largest value, but it also happens to be the most frequently occurring value in left skewed data. And we kind of talked about in the last video that the mean is affected by outliers. So when the data is skewed left or right, we might be looking at some outlier data that's kind of pulling the mean into that direction. So for right skewed data, it's the exact opposite. The mean is the biggest value. So I'm going to flip all the signs. Median is in the middle, and the mode is representing the smallest value. Okay, so here, let's look at this example. Oops. So we are told that we have some authors that show the letter count for each author. Okay, so I was like, okay, what's a letter count? A letter count means the average, or I should say the word size. So the letters in a word. So the larger the words, right, the more the letter count, the smaller the words, the smaller the letter count. And you would expect in like a textbook that probably the letter counts are big or high because they're often giving definitions. But in something that might be written kind of in the more like normal talk where we're trying to just communicate to the average citizen, they'll probably have smaller letter counts. So I just thought that was kind of interesting, learn something new. So what they want us to do is make a dot plot for each of these. So that's going to give us a way of kind of comparing their shapes. So we're going to look at the means and the medians, and we're going to kind of look at any patterns that might exist. All right, so let's start with Terry here. So Terry, we have 7, 9, 3, twice. Oh, 3 times. 1, 2, 3. We have a 4, a 1, another 3, and 2 twos. Okay, so it looked like at first that maybe there were higher letter counts for Terry, but now I'm kind of seeing that was rare. All right, let's go to Davis here. I'm actually going to zoom out since I want to be able to compare these. Okay, so Davis had 3 3s, 2, 3, a 4, a 1, another 4, 2 more 3s. Sorry, I lost track there. Okay, so 3 3s, a 4, a 1, a 4. I said 2 more 3s because I saw the 3 coming up. There's also a 2 I skipped over, and a 1. There we go. All right. So there is Davis. All right, so Maris, let's do this one here. We have a 2, a 3, 3 4s, 2, 3, 3 6s, 1, 2, 3, an 8, and another 3. Okay, there we go. So now we have the basic dot plot for each. And I could kind of see already what's going on here, right? Terry has a couple of large words that got thrown in there, and it looks like we're kind of seeing a right skewed data. All right. For Davis, it's all kind of pretty grouped, but maybe there's a bit of a skew. Well, we're going to look at the mean and the medians and the modes to help us with that. The modes will be there too. And then for Maris, it looks a little bit symmetrical. Again, let's look at the means, the medians, and the modes. So let's start with the mean for each group. Okay, so for Terry, I'm getting, and pause the video, double check. I'm getting a mean of 3.7. For Davis, I'm getting a mean here. I'm going to zoom in just for writing it out. Trying to squeeze it in here. Rewrite that. Okay, 3.7. All right. Davis, I'm getting a mean of 2.7. And Maris, I'm getting a mean of 4.6. Interesting. Biggest of all. Okay. All right. And now I want to also, here, I'm going to write that down here. 3.7, 2.7, and 4.6. Okay. So now I want to go ahead and do the median for each of these. So actually, I'm going to kind of use the pictures to do the median. So I can see, let's see, for Terry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So if I kind of counted down, the 5th piece of data is going to be in the 3s. So I could see that the median is in the 3s. And you could check, go back to Terry's data, put it in order, make sure you get 3 for the median. For Davis, I'm getting also 3. If I'm counting out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, because they're all 10. So yeah, he'd also be in the 3s when you put it in order. And this last one, 2, 3, 4, 5, 6, 7, 8, 9, 10. So his median is in the 4s. Okay. So there we go. So there's the mean and the median for each. And we could kind of now do a little bit of a better comparison between which one's bigger and which one isn't. So the closest of all of them is here in the middle one in Davis's. So in Davis, the mean and the median are very close to each other, and they happen to be close to the mode too, which is 3. So I would probably go ahead and conclude that this is probably considered more symmetrical, which it does look a little bit more symmetrical. It's grouped up far closer together than the others. All right. It's really this last category with the extra 1 that makes it look less symmetrical, but comparing the mean, the median, the mode makes me kind of feel comfortable saying probably symmetrical. That extra 1 is pulling the mean down a little bit. So it makes sense. Here, when I'm looking at it, there's a little bit bigger of a gap. And I definitely feel like the 7 and 9 don't quite fit the rest of the data. So I feel pretty darn comfortable saying that this is right skewed. And then looking at the last one, again, they're a little bit further apart. However, I don't see as much of a weird outliers as I do with Terry's data here with Maris's. So I kind of see, all right, so the mode is 4, the median and the mode are equal. And that's been actually the case in all 3 of these. The median and the mode were equal. But actually, this is bimodal. 4 and 6, they're the same. So there's 2 modes in this, and it is possible to have 2 modes. So they call that bimodal data when that happens. You write that down. This is bimodal, since it has 2 modes, which are 4 and 6. All right. But it still kind of qualifies a little bit symmetrical just based on the general shape of the dot plot. They are relatively close in value, but there is an argument to be made that the fact that the 8 is out there does kind of pull it up a little bit more than maybe it should. So it might be slightly right skewed. But we'll go ahead and say symmetrical, though I think that's a little bit subjective. So depending on who's making the call, it may not be called symmetrical for everybody.